Hello everyone, it's me Pedinla Shilpa from Sikkim Government College, Kamrang, Namchi, bearing roll number 21NS0-240 from second semester, Maths Honors. I'm here to present a presentation on my topic, thermodynamics. First of all, we are going to see what actually is thermodynamics. So, thermodynamics is the study of energy, principally heat energy that accompanies chemical or physical changes. Some chemical reactions releases heat energy. They are called exothermic reactions and they have negative enthalpy change. So basically we are going to study about thermodynamics and its so now basically thermodynamics was introduced by a scientist whose name was Nicholas Leonard Sadi-Carnot, who is also known as the father of thermodynamics, who in 1824 published Reflections on the Motive Power of Fire, a discourse on heat, power, and energy efficiency. This marks the start of thermodynamics as modern science. So here we have four types of laws of thermodynamics. Firstly, it's the zeroth law of thermodynamics, but in actual it was known very late. It was introduced very late, and the first which was introduced was the first law of thermodynamics, and after that it was second law of thermodynamics, and after that it was third law of thermodynamics. After all these three laws, the zeroth law of thermodynamics was introduced afterwards. So now starting with the zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two bodies are individually in equilibrium with a separate third body, then the first two bodies are also in thermal equilibrium with each other. So now basically looking at the diagram we can say that if body C is equals to body A and body C is equals to body B, then body A is also equals to body B. So now next, speaking about the first law of thermodynamics. First law of thermodynamics, also known as the law of conservation of energy, states that the energy can neither be created nor be destroyed, but it can be changed from one form to another. Now moving on to next, we have second law of thermodynamics. It states that the entropy in an isolated system always increases. Any isolated system spontaneously evolves towards thermal equilibrium, the state of maximum entropy of the system. And now looking at the example, when a hot object is placed in contact with a cold object, heat flows from the hotter one to the colder one, never spontaneously from colder to hotter. If heat were to leave the colder object and pass to the hotter one, energy could still be conserved. The third law of thermodynamics. Third law of thermodynamics states that the entropy of a system approaches a constant value as the temperature approaches absolute zero. Now moving on to the example, the molecules within the steam move randomly. Therefore it has high entropy. But if these vapors are set for cooling this steam to below 100 degrees Celsius, it will get transformed into water, where the movement of the molecules will be restricted, resulting in the decrease of entropy. Now talking about the application of third law of thermodynamics, we have an important application of the third law of thermodynamics, that it helps in the calculation of the absolute entropy of a substance at any temperature T. This determines that the determinations are based on the heat capacity measurements of the substance. For any solid, now looking into the application of thermodynamics on our daily life. Heating and cooling systems in our homes and other buildings, engines that power our motor vehicles all incorporate information from the thermodynamics to make them perform well. Now looking on to some of the daily examples. Sweating in a crowded room. In a crowded room, every person starts sweating. The body starts cooling down by transferring the heat to the sweat. The sweat then evaporates, adding the heat to the room. Looking on to the advantages of thermodynamics. Thermodynamics gives the foundation for heat engines, power plants, chemical reactions, refrigerators, and many more important concepts that the world we live in today relies on. Beginning to understand thermodynamics requires knowledge of how the microscopic world operates. Limitations of thermodynamics. The limitations of the first law of thermodynamics is flow of heat. It does not say anything about the direction of flow of heat. It does not say anything whether the process is a spontaneous process or non-spontaneous process. The reverse process is also not possible. In actual practice, the heat doesn't convert completely into work. Conclusion about thermodynamics. Thermodynamics is the study of heat as a special form of energy exchange. It is thus a branch of energetics, the general science and the form of interchanges of energy. Thermodynamics gives the foundation for heat energy, power plants, chemical reactions, refrigerators, and many more important concepts that the human world we live in today relies on. It is actually the branch of physics that studies how heat changes to and form other energy forms. An example of thermodynamics is the study of how heat changes between a hot object and a cold object. And now looking on to some examples that we have in daily life, it's melting of ice cube. Every day ice cube needs to be maintained at a temperature below the freezing point of water to remain solid. Another is taking bath, and another flipping a light switch. Thank you everyone for watching this video. Hope you liked it.